Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the discussion and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show increases the live audience, of course, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we are joined by A Plain Truth, Mark Doxy, Arwin, and Spurs. How are you all doing? A lot of background noise.
Good afternoon to one and all.
Ah, that's Plain Truth.
Hello.
Hello. Good to have you here.
Yeah, so I was just saying earlier on, well, just moments ago, that it's kind of telling what you're doing. You're showing that it's very difficult to prove the globe, or that we're rotating without presuppositions. It's like you're tightening the knot, so to speak. And it was interesting, hearing Charles. He's trying to find a way how he can, explain his version of events without presupposition. So it's interesting for the audience, especially for the people on the fence, who expect globe believers to provide, instantaneously, proof and evidence that we're on a spinning ball. It's supposed to be, like you said, it's supposed to have been over 2,000 years, so it shouldn't have been a problem. So again, it's kind of interesting for the people on the fence, I think, that are waiting, looking for the authority to tell them that you're wrong, that we're wrong, and they're right. So yeah, I think it's a good way. I mean, I'm not sure if people are, they're kind of like, well, you're coming at them quite fiercely, but we're all asking the same question. It's not.
Can I hog the mic a sec before the link goes public? Yeah. I spent time in the hangout in the break. We are live now, yeah.
Yeah.
I spent time in the break to watch the second half because I couldn't remember what the point was that he made in the second half. So I wanted to see whether there was anything credible in the point that Alan was referencing, which he didn't know what he was referencing, but somebody had told him, tell him to play it from 6 minutes. Tell him to play it from 6 minutes. And what happens is after 6 minutes is that Scott Veach says, you guys are quite right. You are reducing the height of objects over distance. But what you're not considering is that the bottoms, the bases of things, moves up, and that lifts the object back up again. So what he's doing is making a point which is correct, but that's not the point that I'm making. I agree that everything goes up to the horizon, right? I've been saying that for ages. You guys angle your camera down, but we see everything that goes up to the horizon because of perspective, including the base of whatever the target.
Where's that shown in his diagram?
But my point is,
where's that shown in his diagram when he showed a side elevation and moved things around relative to shelves? Did he show the thing getting compressed at the bottom as he moved it?
No, he didn't show that. He didn't,
right.
He's
it's
arguing
just a point that validates our point that you've got a convergence point with stuff getting smaller from the top and bottom, but he's using that in his argument, even though he doesn't account for perspective. Outrageous.
Correct. So what he's done is he's making a point from 6 minutes onwards that I agree with. However, it's not the point that I'm making. The point I'm making is that you guys are applying the hidden value. When you put the maths in the curve calculator and you put in your distance and your observer height, and then you get the refracted hidden value of, let's just say it's 300 feet. You're applying that 300 feet against the full height of the target. Now, I agree with you that the perspective makes the base of it rise up towards the horizon, but that's our argument. My point that I'm making in this particular argument is that the angular size of that target reduces. So he's making a point that I agree with, but that's not my point. That's called the straw man. I agree with the point he's making at 6 minutes. It is the other half of perspective, but that's not my point. My point is that the angular size appears to reduce over distance, and you guys are applying the hidden value to the full height of the target. You're not applying it to the reduced height because by perspective. That's my point, and you're not addressing that point. You're making a straw man argument from 6 minutes onwards. That's not my point.
Nice that he's acknowledging perspective whilst not calculating for it. What an outrage.
Or not. Yeah, he's acknowledging perspective and not calculating for it and demonstrating it orthographically in his drawing underneath.
Yeah,
how disingenuous
outrageous.
do you want to get?
These people are perspective deniers, and they've got to be. This is the crux of this. They've hidden what we see, and they've replaced that with curvature. And they say nothing else obscures anything ever. It's only curve, things dropping behind a curve. That's it. That's all you need to count. Look here, side view, side view. See? The straight line I draw shows that it should be hidden by this amount. Oh, really?
Correct.
What about if we look at it in the actual view that we get with things getting smaller into the distance? Oh, well, that doesn't happen. Perspective doesn't need to be accounted for. The actual hidden value remains the same. No, it doesn't. I can do it with just a couple of DVDs. Just move it back a few feet, and what do you know? It gets obscured.
Yeah. So basically, what I'm saying to ballers here, I mean, I think most flat earthers get this. It's the ballers that don't get it, but I know that M. Scott Veach does get it. Go to M. Scott Veach's channel, find his most recent video. It's 11 minutes. He calls it less than 5 minutes, debunking Riley in less than 5 minutes, but it takes 11, which in itself is it's ridiculous. But anyway, find his video, watch it from 6 minutes onwards, and watch him make the point that I agree with. That's not my point that I'm making. Remember my point. Objects in the distance appear to get smaller, and you guys are applying the refracted hidden value against that. That's wrong. You should be applying it against the reduced angular size because of perspective. So don't make a straw man at 6 minutes and then claim that that's somehow in whatever. No, my point is clear, and I'll say it again. You guys are applying the refracted hidden value against the full height of the target. It should be applied against the reduced height because of perspective. It's really simple.
Yes, we should calculate it after performing the function of reducing its angular size. So obviously you can't just arbitrarily lob off a number of feet, because that's not where you should be getting the measurement from. The way it should be calculated out with how big is it based on its angular size, how big is the angle that you are achieving between you and it. And obviously that angle decreases with distance. If you're standing right next to something 6 foot tall, or you're standing 3 feet away from it, it basically occupies your entire view. Whereas if you put that wall at 30 miles away, it's gone. It's disappeared. Why has it disappeared? Well, because its angular size is too small to resolve at that distance. So it looks like it's gone. It's being obscured by the convergence point, i.e. by perspective or anything in the foreground that happens to be larger than it is, based on perspective, not based on actual size.
Now let's put all this back into context. The reason why he has to argue this, and in this instance, is the cannon fodder. Somebody said to him, someone needs to go and argue this, and M. Scott Veach presumably has either been chosen or he's volunteered, but they have to argue this point because the effect of it is that that target now is reduced in its size and followed the curve of the Earth. It'll now, in most instances over 25 miles, never match any of the observations that we observe because we see stuff and it appears to be flat. So they've got to make their maths appear to be flat, and that's what they've done. So they have to argue this point because they need to keep that actual height preserved. They can't have it being the apparent height because of perspective, which is our point. You guys have to argue this, make it sound obfuscated, make it sound a little bit more complicated, make us sound that we've made a mistake. No, you guys are the ones that are lying. Anybody that can come in and argue otherwise, bring it on. Let's see who's going to fight for it, because none of you can actually fight for this with any level of honesty or integrity whatsoever. And guess what? Riley spotted it. Riley shouted it, and it's a mathematical construct that Riley spotted that's deceptive. All that time when you guys have said that this about that about Riley and maths and whatever.
Is that a real Renty?
You know, it turns out that it's maths that you guys have got
Hold
wrong.
on. Is that real Renty?
That's the real one. It is, yeah.
Oh, thank
Can
God.
Can I ask a question to Nathan and Anthony as well, but mainly for Nathan? Well, just about how do I put this? How do I phrase this? So, let's say for example the ballers, they all concede and say, okay, it's not a ball, it's not a globe, it's can are they allowed to say, okay, so now we're going to show with science where we live, or is it a case of those that say like they're on a ball and they now have to give us the 2,000-year-old science? So I mean, so like I mean, where does
I address this.
Just trying to help Charles out a little bit. How
they want,
where does where is Charles's starting point? Should he say, like he was trying to walk through, okay, so it's a blank slate, but now Charles personally can prove to you scientifically, that we live on a sphere. So
there's only one way to truly prove.
Hold on, Arwin, that's not what he's asking.
No, I'm asking him. What the question is: should we now, like all of us, concede, like take the notion of where we don't know where we live, start from scratch, bring in whatever it takes to scientifically, of course, to get that understanding. So, you see what I mean, Nathan? Just to help the borders a little bit, so they know
what we should do going forward. The problem, which is why I get so angry with people like Charles, is that they say, well, I can go out and measure it going forward with no assumptions at all. That doesn't change that he will go to his class and tell them as a fact that it is a sphere and it's backed by science. That's what they do all day long. Hey, Charles, how you doing?
Hello. Hopefully you guys can hear me okay.
Yeah.
Yes, we hear you.
I'm going to put myself on mute.
Nice. Oh no, you're not.
Oh no, I was just asking Anthony as well. I mean,
Charles isn't good on bloody mute.
What someone provides me as a justification?
If every person conceded right now that, okay, so we're not on a, let's say that, where's their starting point? Do they start from the 2,000-year-old science, or do they have a fresh, like now, today, this generation gets to find out where we live?
I think it's safe to say by now that you can't accurately measure a curvature by measuring surface points on a horizontal line. Basically, it doesn't work out. That's not how you measure three-dimensionality. So if you're going to just measure points on a surface and then use the optical phenomena of how they seem to be deviating over vast distances, and you're going to assume that that has something to do with any three-dimensional factor, then you're approaching it the wrong way, because in reality there's only one true way to actually measure physical three-dimensionality, and that is to triangulate it.
Well, no, actually, no.
And that's not triangulation over a surface.
So that's
actually no.
I'm asking you that.
I'm telling you now. I said it yesterday at the end of the hangout how you could do it. I'm gonna now say it again. There's only one way to actually do it, to prove a three-dimensional curve.
But hold on, you're telling people now how to go about.
Still there, Spurs. We lost the panel. Everyone dropping. There will be a short intermission. Oh no.
Yeah, I'm still here. The panel looks like they're still there.
Oh, what a shock. Just got you, Charles.
Oh.
Right, let's start a new hangout. Sorry about the interruption, people. There'll be a short intermission. Welcome to the show. So there is links now published in Skype. Give it maybe 5 minutes before I stick the public link out again.
That was pretty impressive. Imitating me and then
Hello.
leaving the hangout, making it look like I've left and rejoined, and then sniping everybody with my sock account. That's impressive.
Yeah.
Very creative. No plain truth.
Busy day.
Busy, busy.
Yep.
150 people watching though.
I was in the middle of my explanation and somebody sniped me.
We all got sniped.
Yeah, I mean, you were kind of misinterpreting his question though. He was kind of asking me what would you require from them, not what you. If you're saying you can't do it going forward, what exactly is it you're asking for? I think that's what Spurs was basically
Physical
saying.
proof of curvature.
Well, right, you want scientific evidence of the R value, because when he says
No,
I go out-
exactly. That's absolutely ridiculous. No.
Oh,
You could eventually get to an R value once you physically prove curvature. But you actually have to do it, and you can't do it just by making measurements over a surface.
right,
That's not how
that
you
was-
have to actually physically three-dimensionally triangulate the surface.
Well, that's
by
what
going
Plain Truth said
through
yesterday.
it.
It's like you draw your line between your two cities and then just
No.
make the leap to curvature from there.
Yeah, but they just use misinterpretation of optics to get their curve in there, to get their 3D factor in. But that's not how you actually measure three-dimensional arcs. You know how you measure an arc? By going in a straight line from one point in the arc to the other. So there's only one true way to measure curvature, and that is to dig at an angle, a perfect straight tunnel, dig at an angle downwards in a certain direction, and then at some point, if the Earth is literally a sphere, then you should end up in a straight line at an angle upwards on another side. It's very simple. And then
Yeah,
if
so-
you can look through the tunnel and measure that it is perfectly straight, basically see through the other side, see the daylight on the other side, and then you walk over land in a straight line towards the other tunnel, and the distance is larger than going straight through the tunnel, then you have physical curvature. And that is the only possible way to absolutely prove physically that there is curvature.
Thanks to Sarah for the super chat. Much obliged. Really appreciate it.
Yeah, that's how I would do it. But
By the
you're
way,
not
can I
gonna do it?
Can I just introduce a segue? For those of you that subscribe to myself, I put a channel up, a video last night up, where I've been challenged by a baller to do. Basically, the argument was you can't pass a physics GCSE exam. So I found someone that could do this, and we were going to do this, right? Unfortunately, the guy that's going to do this or was going to do this has got a community guideline strike or a copyright strike by the exam board that we were going to use the actual paper of. The actual exam board, someone's complained to the exam board, who have then stopped it from happening on YouTube. So it now means that we can't actually do the actual paper. So we're going to have to do a representation of the paper, which isn't the actual paper because of guideline strikes with YouTube. Apparently, it's censored. So not only is the education not public domain, and I'm not allowed to do it through using their material, they don't want it to be public. They don't want us to go through this paper. So shout out to the I'll not say the exam board, but there is a particular exam board that's put a sod it. Can I say it, Nathan, or should I not?
I don't see any reason why you shouldn't be able to say it. Why wouldn't you be able to say it?
AQA exam board have put in this community guideline strike or copyright strike. I'm not sure which it is because they do not want their material being used. Yet it's put state funded. It's state material. It's for it falls under fair.
Sorry to interrupt you, Anthony,
it
but
top
do you not
secret?
think that's reasonable if it's an exam? Because you're publishing the exam.
Yeah, I think
That's
that the whole
perfectly
point of fair
reasonable.
use is to
That's
use
perfectly
material
reasonable.
for fair.
If you've got an exam, then you can't publish the exam because then people get to see the exam.
No, the exam's been and gone.
Past papers.
Right.
The exam's been and gone. So it's like, well, what's the problem with it? Is it just that they don't want us to use the material, or is it that they're trying to censor? You know what Rumpus would say? You can't censor reality, Nathan. Well, is it perhaps the case that they're censoring the education that they're teaching the kids? Why would we not
I'd
be
have
able
look
to do an
into
exam
it, 'cause
paper?
I'm sure they would have a reasonable reason why, you know, an exam that's... I know it's sat already, and I can't, on the top of my head, think of a reason why. So, yes, on face value, what you're saying seems reasonable. But, on the other hand, there must be something that they would just say, well, for this reason, i.e. maybe some of the questions get rephrased in a later exam, or something along those lines.
Yeah, but they release past papers. It's not. It's public domain. They have to release state funded, isn't it? It's freedom of information requests and stuff like that. They have to release them afterwards because it's state.
Well, can't he
not
challenge
private.
Does it? Well, maybe it's community guidelines then. Maybe it's something in YouTube's terms of service that precludes it.
I know it just seems funny that we put an advert out saying that I was going to do the live hangout with the actual paper, the actual questions, the kids that did it this time round, and now we're not. Apparently, it seems that we're not allowed to do that unless we don't show the exam paper and ask the questions verbally, which seems a bit disingenuous. We'll get criticised for not being like truly honest with what we're showing and all that. We'll be able to prove that it was an actual exam paper. Kind of defeats the whole point of doing it, really, in my opinion. But yeah, that's what's happened. He's been told his video that advertising it's had a copyright strike on it or a community strike on it, one or the other. How ridiculous is that?
Interesting.
I wonder if M. Scott Veach's got anything to do with that.
Oh, God, here we go.
Anyway, Flat Earth Math. We could do with getting him the link so we can come back in, because I don't want him on mute. I want his toes to the fire. I want to hear what he's got to say about this R value that he claims that he can scientifically produce. Because the only way you can realistically
He could do it, but
I agree
start
with
digging.
Yeah, the start digging point would only because it would be subject to the contour of the land, wouldn't it?
Yeah. So.
Well, you could dig a channel, dig the downward bit, then go out at exactly the right 90-degree angle from it. But then, depending on the shape of the land,
no, a straight line.
Yeah,
a straight line downward. It can be just very slight. You could dig down at a 5-degree angle. And then you can calculate with the presupposition of R at what a distance you would basically come back up again.
We've already got it with the channel tunnel.
Yeah. So the thing is,
take a position aside the channel, just right beside it, like 100 feet away. Start digging a channel parallel to it. Go down at an angle, and then. Yeah, I promise you, eventually you will turn back up again because there is curvature, right?
Yeah, but it would depend on the terrain that you're coming out the other side at. It would have to be...
No, not if you do it right beside a channel where you have level water. Then you pretty much know that it is level. So you can check it out by measuring water
you'd have to do it in
parallel
Holland.
To a channel.
You'd have to do it in Holland where the land is like flat.
Yeah, don't do it on a hill. That's ridiculous. Yeah, if you dig straight through a mountain, yeah, you're gonna get out straight. But the whole point is, you have to start out the digging not level. So you have to go down. That's the true way to do it. If you just dig straight at level, straight directly forward, yeah, you will go through a hill. But the point is, if you want curvature, then you have to dig down at an angle. And then if you come back up, then there's actual physical curvature.
What did you say, Nathan?
Someone's moving their microphone around and I can just hear...
Oh, sorry, that was me. Sorry. I need to put my screw back in, though. I've undone my screw. So bear with me one sec while I put it back in.
Pop yourself on mute.
Oh, well, we could do it a bit simpler than digging. If we did it through a stretch of ocean with just concrete pipe, make the concrete pipe dead straight.
yeah. Could do, but yeah, it's gonna be a lot harder for them to do because everyone with the shovel can dig. But yeah, building pipes and everything in the ocean, that's gonna be like an industrial finance project. I doubt these Globers have the resources for that.
No, they don't.
But anyone can just start digging, just dig at an angle down, and really there's curvature, so you're gonna end up back up.
Wouldn't you be able to just modify that a little
straight
bit?
Line.
Mark, wouldn't you be able to just modify that a little bit and just do fiber optics? So you would just do a cable. If you can get a 5-mile stretch of cable, that would still produce the same result.
Yes, it would, wouldn't it?
You know what I mean? You wouldn't have to do concrete. You would just have to do something they've already got in existence Where, you know, like, oh, we had an excess of 5 cable that we're not using anywhere. What are we going to do with it? You know, you would just use something that's already there.
That's interesting.
That would
Or
be
just
it.
have a little look, like this lighthouse. Just have a little look at the world around you, and you see it's
the
flat.
concrete tunnels of that one, yeah.
Well, the other way you
Yeah,
could
but that's
consider
still
doing
over the
things-
surface, so it's subjected to optics. It's not a way you can measure a 3-dimensional object. So it doesn't work. You can only measure the distance.
It's ridiculous though, because the idea is that this refraction is looming this up from behind the curve. It sounds
That's
preposterous.
absolutely
I
ridiculous.
mean,
Yeah.
even if it was true, it still sounds preposterous.
I don't know what's going on with your mic.
Me,
Yeah.
I've stopped playing with it.
Okay, I'll
That's
turn you
not
up a
me.
bit. You've just got quieter, that's all.
It's nice.
You say it's nice.
Shut up, Arwin.
You're always talking through it when I'm explaining.
It's all right. You're all
Got a
level
good
now, I think.
explanation. Hey,
Anybody-
at least I got a suggestion for what the Globers can actually do to prove curvature.
Go on,
It'll keep
let's
them
hear it.
busy. It'll give them something to do with their lives. It's nice.
Well, I don't know. I think that for me, the only way you can actually measure R is to realize and accept that R is the point from the center of the sphere out to the edge. So you either have, I mean, obviously you can't measure R because that would be the center of the molten iron core at 2000 degrees, apparently.
No, but you can still measure R by taking a shortcut and then just measuring how much the arc is by taking the shortest point
Guys,
between
can I just say something?
one part of the arc. If you'd actually have to do it everywhere if it is a consistent curvature, but you can just measure one piece of curvature by digging a straight line in between 2 points on the curve.
Anthony, would you
Hey,
be
the
able
boss.
to answer
How you
this
doing? Can you hear
question in
us?
chat?
Hold on a second, Ranty. Can you hear us, the boss?
Hello.
So it's gone.
Hello, good to have you.
Nice to be on.
Who's there?
Anthony, there's a guy in chat, Paul Hill. He says that you can measure how much the horizon falls below level at various heights with the theodolite.
Yeah, Rumpus says that as well. There's a video debunking that notion on my channel.
Well, you saw the videos and the photography that I showed where you couldn't actually see the actual horizon or make out which was which. I was hoping you might have that evidence to hand to show them.
I don't have the evidence, but I have the video that addresses that evidence. It's called.
Do you not have the dog? The floaty dog?
I
Yeah,
do,
I've
but
got
it's in the video. I don't have that evidence here.
I've got it on
Alright,
every thumbnail on the backup channel. So if you check the link in the info box to the audience, there's a link to Nathan Oakley channel as opposed to Nathan Oakley 1980. And on that channel, I mirror each and every one of these debates. So if I should ever fall victim to a community guideline strike, then I can just stream on that channel for 3 months. But yeah, so subscribe to Nathan Oakley, that's the first point. But the second point is that every thumbnail I use for these debates has the image of the guy levitating, the runner, same image, you know, with the guys floating above the horizon. In other words, it demonstrates very well that there is an apparent horizon, because the horizon's a line and then there's a guy who's obviously not floating. It just appears that way because the horizon that the land he stood upon has disappeared and is subject to an inferior mirage of the sky below because he's right on the convergence point. So therefore you do see him, but you don't see the land he's standing on, so it looks like he's flying, even though he's not.
Wait, what is the guy standing on?
Well, he's standing on the ground, but it's just he's behind that point of convergence, and then on his
No, like,
feet,
what kind of
you've
ground?
got an inferior
Like, is it
mirage of
dirt,
his own feet.
sand, cement?
It's
So he's-
sand.
Sand?
You can see an inferior
So
mirage.
you know when you're on a road on a hot day and you see how the road looks like it's reflecting stuff, but it's actually not. It's the same thing.
Yeah, similar.
Yes.
Yeah.
So how would you know
It's
whether
heat
the horizon is?
miraging.
If
That
you
doesn't mean
was
anything.
looking out to sea and the ocean was doing that same effect that you see on land, how would you determine where the actual horizon would be?
Well, from where it starts reflecting things.
Yeah, but you can't see a reflection point of the sky. 'Cause it's
Well,
all
you
blue.
can see like a clear difference between like a clear image and then it's kind of blurry on the bottom.
You can't. It merges into one. It appears to be a lower than normal horizon.
Right, but that's not it.
Yeah, but you try arguing that against a baller that tells you it is.
And you try and point a theodolite at that, and then try and make a cohesive experiment explaining that.
And in the converse, you can then get something called a fata brumosa, which is where the water reflects above the water actual horizon. So it appears that the horizon line is higher than normal, and then that would also give the effect of blocking out boats that appear to go over a curve. It also doesn't tell you where the actual horizon is because it appears to be higher than it actually is. And unless you've got some land or some kind of reference point that you can tell that there's a fata brumosa in the way, if you're just looking out at the sea and see the hard horizon, it appears that the sea is higher than what it actually is, or lower than it actually is, depending on what type of mirage you have. And there's always some kind of atmospheric effect on the horizon.
Right, but that's why you need to do it with like some sort of, like you said, a reference point, like land or a boat. Because that way you would actually be able to see the actual horizon, which is where you point the stuff at, and then you can get all the proper measurements, which from that you can actually prove the globe.
But then I'll use Issa's phrase, how dare you use an optical phenomena to calculate anything to do with the shape of the Earth or the size of the Earth? What I'm saying is it's an optical effect that you can't always tell what you're looking at. It appears to be a circle of confusion.
But you can sometimes tell.
Oh, can you sometimes? How do you decide which times?
It's just randomly reliable. Come on.
It's not random. You just have to have some.
Sorry, hold on, Arwin. The question was, how do you know which times are reliable?
If you know what you're dealing with.
Randomly reliable. It's
hold on, Arwin. What direct question? How do you know when it isn't?
When it isn't. Well, when there's the blurry part on the bottom. I don't know when you see the mirage because it's clear. But there are times when it's perfectly clear where the actual horizon is.
When is it perfectly clear? You're just stating that it's perfectly clear at times, and I'm trying to establish when those times are.
When there's no mirage.
There's always a mirage unless there's something obscuring it in the foreground, i.e. waves. So if you can see far enough, there'll always be this circle of confusion. Always.
Well, then you have to do it on a calm day.
Right. So on a calm day when you have a mirage, which is always there, why would you assert that you have an actual mirage, an actual horizon to measure to when you're looking at a mirage?
Well, it's right above the mirage.
So we're not measuring. So we're not measuring the horizon. Then we're measuring above a mirage. So not the horizon. Then.
Right.
Sorry, are you saying we're not measuring the horizon now? We're measuring above a mirage, correct?
Well, that is the horizon because the mirage.
No, that's not. That's a mirage. You're saying it is the horizon? No. Why are you saying this? Incorrect. Why are you saying a mirage is the horizon? The horizon, by definition, is something that is apparent.
Well, if you're trying to measure to, that's what I'm telling you.
No, we're not, because we're not idiots. We wouldn't measure to something that is apparent by nature, because that is stupid.
Yeah, measure the rainbow, man.
Picture of a rainbow.
Can I just voice a little bit? I was thinking, what if we change the mirage to a cloud bank? So let's say, for instance, we're looking into the distance and we're trying to measure the distance and we're like, oh, blast it, there's a cloud bank. Oh, well, let's just go to the top of the cloud bank and measure that, and that'll be our horizon. We wouldn't do that.
You don't want
because we don't know how much. We don't know how much is being obscured. We don't know if there's a mile now that's being obscured, and we're going to be off a mile. So, if, in my mind, picturing it as a cloud bank, that's the same scenario. We'd have to wait for the cloud bank to be completely gone, and then we would say, wow, we would have been off by 10 degrees.
Can you share the screen, Nate?
Yeah, sure. Hold on.
That makes sense to me.
Click on Ranty's face locally if you want to see his picture of Piranha Boat.
Piranha Boat, that's right. And I'm going to play it now. So you can physically see what you would claim would be a hard horizon, but you can also see a distinct miraging going on. So where would you point your theodolite at?
I don't see it on my screen yet.
Okay.
I can see it on the stream, but not on the Hangouts.
Yeah, just click on Ranty.
It's duckboat.
Piranha boat. This one.
You would point it where it's reflecting off of that thing.
But don't you understand that 99% of
Hold
people
on,
would say
Ranty.
that...
Sorry,
go on.
just let get a succinct answer. Where were we pointing at the theodolite?
I don't know how to perfectly describe it.
So hold on. The assertion before you go on, let me just clarify something you said earlier. Just before you go on, sorry to interrupt. Sorry to interrupt. Earlier you said you pointed at the horizon.
Yeah. Well, the actual.
I would point at level.
Right. You just now. Right. That's the problem. We don't have an actual horizon. By definition, the horizon is apparent. To say it's an apparent horizon is actually redundant. By its nature, it is apparent. It's not a physical thing for measuring.
The horizon, as we see it, is basically an optical phenomena.
Right. A convergence point due to perspective, as opposed to something physical you can use to measure. Do you understand, the boss?
Yeah, I do understand.
Right, so the horizon's not useful for measuring to then, right? You understand that also?
It can be in some cases.
No, you are clearly retarded. It is apparent by nature and not useful for measuring something because you can't even establish where to put your theodolite because you don't know where the horizon is. And when you zoom in on it with a super zoom camera, you see that the horizon is not the horizon. And you have to start extrapolating out nonsense like, I'll stick my theodolite just above the mirage. Utter nonsense like that, not exactly precise then, you understand. Hello, Rumpus.
Oh, Rumpus.
Oh, goody.
I think I can clear this up though, Nathan. Because, well, first of all, in this picture, or in this video, you wouldn't be seeing it like this, of course, because...
we are seeing it like that. This is a video recording of actual reality. This is what we see.
No, well, this is zoomed in.
We wouldn't be seeing it like
this.
We do, because it's there. And we're
this is from a 3-foot observation height.
Yeah, I know, but that mirage wouldn't look that thick. Cause...
It does look that big, you utter muppet. What part of this is a videotape don't you understand, you retard?
Well, you're zoomed in. And
it does look like that. That is how it looks. It looks that way because that is how it is. It is a video recording. Don't tell me that that's not how it would look because it's zoomed in. That is how it looks, you idiot.
You can't look.
What he's trying to say is that because it's zoomed in, you don't see it as big.
If you believe in the globe, close your eyes because this is not what you can see.
Right.
My eyes aren't as good to zoom into an object that far away.
Your eyes don't need to be. It's on a screen in front of you, having been zoomed in for you. You don't need better eyesight to see something that's zoomed in. It's on screen for every member of the public who is currently watching.
I'm sorry?
You can see it. Don't tell me what doesn't happen when it's in a video recording.
Well, I'm saying, what do you imagine that the degree of this mirage would be? I know someone said it could be 10 degrees. It could
I don't care. I'm not asserting that you can use it for measuring stuff. I'm not an idiot.
Well, that's what I'm saying is that measurement in this case wouldn't be that small. So let's just move on from this picture and go to where you would see a bigger...
No, that's fine. That picture's fine. That picture's absolutely fine. You can use that horizon as your measurement perfectly well.
That's nonsense. Utter nonsense. You can't use it. There is no horizon there. We've got a mirage effect with a boat reflecting down on itself. So that's not a real horizon. It's not anything that could ever be measured ever because it's an apparent horizon.
It's very close to the geometric
horizons
horizon.
are just apparent.
It's very close.
Just a few degrees off. It's
I thought you wanted to be very
me. Oh, and just try to stop interrupting for once. That is very close. Oh my god. The horizon you can see in the picture is very close to the geometric horizon.
Yeah, but it's not actual, though, is it? You're guessing.
It's very, very close to the geometric horizon. It's
Who
good
cares?
enough.
We're not interested in very, very close to anything. It's not actually anything. It's just apparent. That doesn't matter how many times you say it's very close or just a couple of degrees off. You have no idea how many degrees off it is. It makes no difference.
As someone who gets everything 100% wrong, Auntie, you should understand the idea of being inaccurate.
You have basically said that that is very close.
Yes.
No.
Close enough.
No.
Close enough.
Because, no. If you worked out the circumference of the Earth using your ball Earth bollocks, right? This horizon line that you would be using would probably shrink your ball in half.
No, it wouldn't.
Yes, it would.
No, it wouldn't. Yes, you have no idea. You haven't done the maths, Ranty. You've no idea what you're talking about.
It doesn't matter. The maths aren't important when it means nothing because it's just an apparent horizon. So who cares how much your fantasy maths do or don't match this? It's literally meaningless. It doesn't actually matter in the slightest what your fantasy maths do. So who cares?
Sort of, Anthony.
Stop speaking over everyone.
I've barely got a sentence out, Anthony. Right.
Stop speaking over everyone.
Anthony, I've barely had a sentence. I've been interrupted all the time.
Well, wait your turn then.
Oh my God.
Maybe you should try to make some statements instead of just
nothing
slandering people, because that's what you have done so far.
I've had a sentence out without being interrupted by Arwin. Now, the horizon that you can see there is very close to the geometric horizon. Is perfectly close enough from which you can make evaluations of the Earth's radius. People have been doing this for centuries with sextants, doing that sort of thing, and they've been able to get success in getting navigating. Hold on, Ranty. I'll let you. I won't overtalk you.
No, I just want to ask you just one question.
I've got 5 seconds to go. And people have been using that observation for hundreds of years with sextants successfully. Off you go, Ranty.
Right.
Really?
Okay.
They use sextants to measure.
Arwin, stop interrupting Ranty.
No, I have just a quick
response.
response. I don't think that's what they use sextants for.
Interrupt us. Stop it.
They don't use sextants to measure the curve and the horizon, you dumbass.
Ranty, go ahead.
Right. So you say that this is the real horizon here, where it's mirroring. Yeah. You would agree with that.
It's very close to where you actually see the apparent horizon.
Right, so the apparent horizon is lower. What would that actually do? Would it give you a curve?
Yes.
There we go. So you're saying that the apparent horizon gives you the curve, whereas I was saying that the real horizon shows it perfectly flat from a 3-foot observation.
You don't know where the real
looking at this boat, which is 7.5 miles away, right? 3-foot observation. This is perfectly flat.
Well, you're wrong.
No, of course you would say that.
Flat as a
pancake. Well, no, you've no idea. You haven't done the maths. You've no idea what you're talking about.
Of course you would say that.
You have no idea.
You just agreed that using this line, this apparent horizon here, would give you a curve, and you say that's perfectly okay to use that.
Yeah.
You're basically presuppositioning that it is all right to use this line to give you the curvature that you need.
No, I've done the ray tracing.
You just said that.
Hold on. I have a mathematical basis for knowing where the I have a mathematical basis doing the ray tracing that we've just finished. Well, not the ray tracing we did months ago with Philip. We know where the geometric horizon is relative to the apparent horizon. It's very close in circumstances like this.
So with maths, you can make anything look like a ball, can't you?
No, you can't. That's exactly what you can't do. You can.
Yeah, of course you can. You can give it an apparent radius.
You don't understand maths, so you wouldn't know.
I understand enough to know that. I understand enough to know that if you only have 2 ice creams, I know that I can't physically take 5 ice creams off you.
Well, obviously you can't physically. No one would dispute that.
You say that you can with maths.
You can model such an event, but also you could put a constraint in the maths and say Anthony's not allowed to have minus ice creams, in which case that would hit upon that, but you've got to add that as an extra constraint.
Right. So we can have the same constraint with an apparent radius, can't we?
Do what? Sorry?
You can't have a radius unless you can prove that it's there.
Well, of course we can prove it's there.
Well, how do you prove the radius?
Excellent. Hold on. What's your scientific evidence for the value of R?
Well, you can make the observation we're doing here, or you can use all the receivers I was talking about in the Ordnance Survey I've got, all set up around the country, 72 of them, all telling you their geodetic position, and you can use that as information. I mean,
sorry, I didn't ask for information. I asked for... Sorry, can you stop talking for a moment, please, Rumpus? Like Charles, please can you repeat back to me what I'm asking for? I'll say it once now, hopefully without interruption. I'm looking for the scientific evidence of the R value, please.
It's provided by the Ordnance Survey.
Sorry, first repeat back what I've asked for, because the Ordnance Survey is not a formulated hypothesis based on an observed phenomena. So please repeat back to me what I'm asking for without talking over me. I am asking for something, and I want you to listen to it and then repeat it back, please. I'm asking for scientific evidence of the R value. Please can you repeat that back?
Right, you're asking for scientific evidence, but engineers do that job just like surveyors do it. So
you said scientific evidence of what engineers do. That's not what I asked for. It seems you are deaf. Stop talking and listen to what I'm asking for so you can repeat it back verbatim. I am asking for scientific evidence of the R value. Please, can you repeat that back verbatim?
you were asking for scientific evidence and...
No, there was no and in my statement. I am asking for the scientific evidence of the R value. Please repeat that back verbatim.
You're asking for scientific evidence?
Of the R value.
Of the R value, yes. And engineers...
So can you repeat it back in a full sentence once, please?
No, I'm not going to.
Why not? You're backed by science. Why wouldn't you want to repeat back that I am asking for? It's simply a question. I'm asking you to provide scientific evidence of R. Why wouldn't you want to repeat that back?
Well, because we heard it. You heard what you said. We all know what you said.
High-pitched rumpus. Just repeat back to me. It's a simple question, right? I want scientific evidence of R, but to establish that you have understood what I'm asking for, I want you to repeat it back to me.
Well, I'm not going to. I have understood what you said. And
I don't know that, though, because every time you say something, you give me back something that isn't scientific evidence, like an Ordnance Survey map.
You get professional measurements, surveyors in to measure something.
Measurements. If you've got measurements that formulate themselves into the scientific method, then I'm interested in it. That's why I want you to repeat back to me what I'm asking for. I am asking for scientific evidence of the R value. Please, can you repeat back what I'm asking for?
You're asking for scientific evidence of the R value, and the Ordnance Survey provides that.
Excellent. Can you tell me what, first and foremost, the Ordnance Survey have as their observed phenomena, please?
Not use R.
Hold on, Arwin. Hold on, Arwin. Hold on. If we've got some science, we can get some methodology into it. So, what's the observed phenomena?
If you tell me, if you want to know how an electric bulb works.
No, I would like to know how the Ordnance Survey has formulated itself into the scientific method by first establishing step 1, the observed phenomena. Please.
Well, they would take measurements of the distances between things, but they follow an engineering...
Sorry, the distances between things is not an observed phenomena, you absolute idiot. I'll ask again because you don't understand or you are stupid. What is the observed phenomena?
You're an idiot if you think you can conduct an experiment.
Don't just ad hom me. If you can't listen, I'll just have to kick you out because you seem to be talking continually now. So please don't interrupt me.
Let me make my point.
I'm asking a question. What's the observed phenomena?
The observed phenomena is the distances between their various receivers they have around the country.
Distance is not a phenomena.
It is a phenomena.
Sorry, distance is not a phenomena. Distance doesn't happen. There is no happening with distance.
You've got this confused about happening. You seem to think happening is required. You don't need it. If I want to observe, say, the distance of the planets are in relation to their radius...
Yes, you would need R for that, wouldn't you? To observe the distance of the planets in your world, you'd need some R. That's why I'm asking for scientific evidence of it.
You don't understand. You have to have happening. You do not.
He just tried to put R in by just saying that the false horizon would be accurate enough to measure to.
That's correct.
Therefore, lowering the theodolite so that the angle would give him the curve. He's dishonest.
No, it's not dishonest. It's perfectly honest. Ranty, you've done no math.
Don't use
You have no idea what you're talking about. I have done the rate.
You've just seen you do it. You've done it in front of everybody. Everybody here just saw what you tried to do and get away with.
I'm telling you that the geometric horizon is very close to the apparent horizon. Therefore, it's valid to use the apparent horizon as your measurement.
So the apparent horizon is lower than the real horizon, giving you your R value.
No, I have done the ray tracing, and so you don't know what you're talking about. Ranty, you've no idea. You're just guessing.
You have just admitted it 10 minutes ago.
Surveyors use lasers and they use a level.
You're
they
interrupting
do not
Arwin, you're
use
interrupting
R.
again.
They
You're
do not
interrupting
measure
again, Arwin.
the
Ranty was
radius.
speaking.
They measure the surface of the Earth. You're a liar.
You'll get your turn in a minute.
Talking over everybody. You don't get to tell people who talks on my show, Rumpus. You don't get to do that. I tell who people who talk.
They use lasers.
I'm talking to Ranty.
Stop telling Arwin to stop talking. You're talking over Arwin by telling him not to talk.
Ranty at the moment. Right, so Ranty.
You're not controlling this show, Rumpus. If you tell the guests who's going to get to talk again, I will kick you out.
Fine, I'm talking to Ranty, and I'd like to finish the discussion with Ranty, and I'm happy to talk to Arwin, but I want to finish talking to Ranty. Right, so Ranty, your claim is I've done what? Conceded?
You just said that it's all right to measure to the apparent horizon, which is clearly lower than the real horizon.
No, hold
That
on.
would
Hold on.
be our value.
How are you presuming where the real horizon is, you idiot?
You
Where'd you get that
through
from?
it. You came in, you joined the panel, you said you can clearly measure the horizon on this video or this image. You then proceeded to say that you can measure it using the apparent horizon, which, as everybody saw, clear as day, would give you your R value because you were dipping the theodolite lower than the real horizon.
No, hold on. Where's the real horizon? What basis have you got to make that
Don't
claim?
even go there, because
What
I even said
basis
to you,
have
I
you got
asked
for
you,
claiming where
I
the
said,
real
would
horizon
you agree? I said, would you agree that this is the real horizon? And you said yes. And then you said
Well,
the
I couldn't
apparent
see the- I
horizon,
didn't
which
see
is
your pointer.
clearly
I thought you were
below
talking about the
that,
apparent- I
is
couldn't see-
absolutely perfect to measure
I
to.
couldn't see
That
your
would give
pointer,
you the...
Ranty. Ranty, I couldn't see your pointer.
Don't come back and lie to us.
Look, you twat. I didn't see your pointer. I thought you were pointing at the
You
apparent
joined the
horizon.
panel because you were watching the video.
Look, you point which...
Oh, shut up.
You stupid wanker. I'm talking about the apparent horizon.
No more ad homs. Right, no more ad homs, Rumpus. Stop it.
Twat.
You guys are
no
aware
more ad
that there are
homs. One more and you're out.
ways to measure
Ranty, the real horizon you're claiming is what, where the inversion layer, where the fold line. Is that what you're claiming? Where the real horizon is? Are you claiming the real horizon is where the fold line is?
I asked
and I told you it's where the apparent horizon is, which is where the sea.
Right, that's our point. Well done, Rumpus. You've just been totally schooled by our Ranty. Well done.
So, Ranty,
that is totally owned.
You're gonna
Love
have to
it.
edit this out.
Ranty, do you understand where I'm saying the horizon was?
What
That
a
is
lie.
where the normal horizon,
Past
where you
tense.
see the surface of the sea. That is what I'm calling the apparent horizon. If you were holding a pointer and pointing somewhere else that I missed, then fine. But are you saying that you said the real horizon is? Where do you think the real horizon is?
The question was very concise with a very big image on screen.
Yes,
for you to
and I'm
agree
telling
to.
you that it's at the apparent horizon, is where the geometric and the apparent horizon are very close to one another. What don't you understand about that?
Oh, you're just trying
What
to do
don't
damage
you
control
understand
now.
about that?
You're just on damage control
don't
because
you
you just made
understand
yourself
about
look
that
a
statement?
complete
What
idiot.
don't you understand about
Stop
that
saying the
statement?
same thing over and
Rumpus
over again,
tries-
Rumpus. You're talking over people by doing it, by just saying the same thing. This is why I stick you on mute, because you just say the same thing over and over again so people can't hear what's being said.
He didn't understand what I said, and now he's claiming I don't know what he's claiming.
Don't assert what he does and doesn't understand. You don't know what Ranty does and doesn't understand. Yeah? You guys don't understand perspective.
Ranty, should we clear up the thing about who?
No, you said enough.
Right, well, you see, there's
Yeah, let's get him on perspective.
You can't cope with it, can you, Ranty? You cannot cope with the interaction because you're too stupid.
Man, you just
Nathan, let's get
We don't have any interactive Rumpus. He just starts rambling like a chipmunk.
Ranty started talking and then you carried on talking, Rumpus. You keep doing it. So he started to reply and then you just carried on talking like you're doing now.
You guys are aware that there are multiple ways to find the radius of the Earth, correct?
So give us your scientific evidence for the radius of Earth, please, the boss.
And they all agree.
Let's hear it. Scientific.
Yeah.
Could you repeat the question? I didn't hear it.
No problem. What is your science? No problem if you can be quiet just long enough to hear me. What is your scientific... Is that Alan making that noise, by any chance?
Nope. Jay.
What is your scientific evidence for the value of R, the boss?
You find two locations and get, let's say, a pencil straight up and down, perpendicular to the Earth on two different locations. Find the distance between the two locations and at the same time measure the angle of the shadow. And you can use some math to figure out the circumference of the Earth, and you can plug into the circumference formula to find the radius.
Sorry.
Oh, right. So you're going to use the heavenly bodies to...
Hold on. What's your observed phenomena? I asked for scientific evidence. So step one
That
in
is
scientific... Sorry. Step one is observe a phenomena. So what is the phenomena you're observing, please?
The sun?
That's the angle of the shadows.
Sorry, Rumpus, nobody was talking to you.
Yeah, and I was helping him out.
Sorry, so the sun is your phenomena. Was that Alan? I bet it was. Is the sun your phenomena?
I don't
The angle of the shadow. Just get
Shut up,
underneath the
Rumpus. If
angle.
you do it again, I'm going to kick you out. Nobody's asking you.
Measure the radius of the Earth.
Sorry, I'll ask it one more time. What is the observed phenomena?
The difference between the angle of the shadows.
Yay.
Sorry, the angle is the phenomena. A difference in an angle is the phenomena.
Correct.
Yeah.
Okay, so what's your independent variable?
Latitude.
Rumpus, right, that's it, you're out. You can't keep your mouth shut. Nobody was talking to you or asking you anything. Sorry. So.
Oh, fake sleeping warrior.
I'm still waiting.
No, that.
Oh, he gave you the answer.
I'm asking you.
Oh, well, he said latitude, so it's latitude. He's right.
The latitude is a concept.
Latitude's a concept.
Alan, nobody was talking to you.
It gives you the difference in the angle at the same time.
Ah, it looks like the panel's getting kicked.
Oh dear. But the latitude is what gives you difference in angles, which allows you to measure the circumference of the Earth.
It's a concept. You need something that you can physically manipulate.
Okay, fine. Distance north to south.
So your independent variable is distance.
Yes.
So your cause in this cause and effect relationship is distance.
Sure.
So that's nothing to do with radius.
Well, you can use the angles that you find to measure the circumference of the Earth.
How do you know there's a circumference?
Well, because if you get 3 points...
Sorry, you don't seem to understand. You're not formulating a scientific hypothesis. What you need in a scientific hypothesis is to establish a cause and an effect. That's what you need. So I'm getting muted by trolls now, while we hold your toes to the fire, the boss. So
that was Anthony Wiley that muted you.
No, it wasn't. It was a troll that's kicked all the rest of the guests out. Please don't tell me what's going on in my own hangout. I've been doing this quite some time.
I can read the side chat that has all of these logs.
Right, and somebody has joined as a fake sleeping warrior. Please can you establish what your independent and dependent variable is, because it is not currently formulated into a scientific hypothesis, the boss.
I don't know, I'm not some scientist, I just know that that's how you...
Well, you see, the problem is I asked you for scientific evidence, and now you're telling me you're not a scientist.
Here's a detailed version of what I'm saying.
Just tell me.
It's long. It's really long.
I don't care. I need you to tell me what your independent and dependent variable is in your scientific hypothesis that you claim to have to prove the value of R. That's what I require.
There's multiple, though, of each. Because multiple things are the same.
No, the scientific method has an independent variable and a dependent variable. You are trying to establish a cause and effect relationship by manipulating the independent variable to vary the dependent variable. That's why I'm asking you for these things. Once you have these things, you can move forward and start experimenting. But so far, nothing you have provided is scientific. And I am asking for scientific evidence of R.
Okay, the things that can change is the 2 locations on the Earth. Which then
Fuck
change.
my ass. Yeah.
Are you done?
You take your time. Independent and dependent variable for your scientific evidence of R.
I'm sorry, I'm just getting distracted by all the trolls.
Don't get distracted. Just worry about giving me scientific evidence of R.
So, that's dependent. The angles are dependent. The angles are dependent. What remains the same is the fact that all sun rays are parallel, which then gives you the different angles based on your different locations on the
Sorry,
Earth.
saying that all the sun rays are parallel, that's a presupposition.
It's actually been proven, so you can use other proven
Sorry,
facts.
we're not trying to prove sun ray angles. We're trying to prove scientifically the value of R.
Yes.
To then measure the circumference of the Earth, which has already been pre-established by other experiments to have a circumference.
What experiment?
Use that.
What experiment?
Can you let me finish and then I'll elaborate
Yes,
on that?
you've said it's been established that there's a circumference to the Earth with an experiment. So I'm saying no, that's a presupposition. Tell me what experiment.
Not the one that I'm explaining to you is how to measure it, but people have already observed the fact that it is spherical.
You said there was an experiment. What experiment? What experiment?
Wrong word. I have, in fact, used the wrong word. I did not mean experiment. I meant observations.
What you know about Bang? It's a team sheet.
I just woke up. It's 10 in the morning, okay?
Sorry, you would need an experiment for it to be a scientific evidence. That's what scientific evidence has.
Well, it's scientific that trees are green, but you can make an observation.
Sorry, no. Science establishes a cause and effect relationship. To establish why leaves turn brown would be something you could formulate into the scientific method. Whereas just saying that trees have green leaves and that's scientific, that's nonsense. You're trying to establish a cause and effect relationship with an independent and a dependent variable that you isolate.
It's an observation, not an experiment.
Sorry, an observation is not an experiment.
Yes.
What do you mean, yes?
That is correct.
No, an observation is not an experiment. An observation
I
is
know,
most certainly
that's
not
what
an
I just
experiment.
said. That's what you just said.
So, do you have any scientific evidence of the R value or not?
I have not done the experiment myself.
What experiment?
The one that I have been explaining to you, and I can link to you again.
Well, tell me, what's the observed phenomena?
The fact that there are differences in shadows, and then you can use that difference to measure the circumference of the Earth, which then can be used to find.
So, what's the independent variable?
The fact that the sun rays, well, that remains the same no matter what. The only thing that will change is your...
So your independent variable is the fact that something remains the same and constant. Is that what you're saying is the thing that you will be manipulating and varying? Is that correct?
Nathan, keep your story straight.
Is the angles which you
You're lying to all these people. You're kicking people off. Nobody believes you, Nathan. You're crazy. You're a
you,
twat.
Rocky? How you doing? That's a really great...
Suck a big black dick. Suck a big black dick.
That's a fine rebuttal. So, what's the independent and dependent variable in this experiment? I'm still not getting it.
The independent does not change. The fact that the sun rays remain parallel does not change. Your location on the Earth.
Do you understand what a variable is? Do you understand what the word variable means? I'm just looking for a yes or no, whether or not you understand this simple English word. The word I have asked you if you understand it or not is variable.
No, an independent variable does not change.
I think that's pretty much going to be the point that I round out this show. This idiot, known as the boss, has literally just asserted that an independent variable, the part of your experiment that the researcher varies, does not change. that is most definitely the point that I'm going to round out this show, because that is quite literally the dumbest thing I have ever heard in my entire life. So with that, I will say, first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And a massive thank you to all of the debating panel for making this debate possible. If you hated the show, then you know exactly what to do. But if you like the show, then maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!